Here's a solution to quiz 3. Quiz 2. There were multiple versions of this, so I'm just going to go through the concepts and setup, and you can check your own final answer against this. In the first problem, this is a problem out of section 6.1, where we are given a population function and we're asked for a population value. So the main thing that people mess up on this is that you really are trying to, well, I don't know what to tell you. Here's what you should do. The fundamental theorem of calculus tells us that when you integrate p prime of t from 0 to 12, that will be p of 12 minus p of 0. So we know for a fact that's true. That's the fundamental theorem of calculus. So that means that the antiderivative of this function has something to do with the answer, but it's not just that. It's not just the antiderivative that's the answer. So on this side, we can actually do this. So we just over here. I guess I'll write the function down. So we're given that p prime is, for this version, it's 325 minus 5t. And so that's easy antiderivative. And evaluated from 0 to 12. So that will be a particular number. Let me just erase this line. So this will be a particular number. We plug in 12 into this thing, plug in 0, subtract, and let me see what I get. Okay, so this comes out to be 3540. So again, that is the net change in population. That's why we're using this, the fundamental theorem of calculus. The integral is the net change. So in other words, it's the population at 12 months minus the population at 0 months. That's what this derivative tells us, and that's what this is. So if the net change between P12 and P0 is 3540, then P12 is going to be 3540 plus the initial population. In other words, we know that this is 1,350. So therefore, this guy has to be 3540 plus 1350. So the tendency on these kind of problems is for people just to just find an antiderivative of whatever's given for p prime, and then just kind of go with that in some way. But if you do that, then you're getting an answer that's relevant to the final answer, but it's not actually answering the question. In part number 2, since the question here just asks how high above you the ball is, then that really is the displacement. In other words, if you figure out the position of the ball at 4 seconds and subtract the position of the ball at 0, that is exactly how high above where the ball started. So it's the same deal here. I'll use the letter S for my position function like they do in the book. But again, if we start with the fundamental theorem of calculus, then we can't possibly get this wrong. So the integral of the derivative of position is just the net change in position, S of 4 minus S of 0. And S of 4 minus S of 0 is exactly the answer that I want. However high I am above sea level or whatever at S0, in other words, whatever the position of the ball is at time 0, this difference is going to be the change in that position. So all I got to do is do this integral. The integral from 0 to 4 of 108 minus 32t is 108t minus 16t squared, evaluated from 0 to 4, whatever that is. So that will be the answer, because in this case it really just wants displacement. If I had been given here that when I released the ball, I released it from like 6 feet in the air, and I want to know how high it really was, then it would matter that I was measuring displacement here and not height. So my recommendation, and I said this in class, is always start off with the fundamental theorem of calculus and then work out what it is you're trying to answer. Now 2b is more of a physics problem, and it's trying just to harken back to what you learned in Calculus 1, which is that a maximum happens when the derivative is 0. So if you wanted the maximum height, you want to know that should happen where the derivative of position is equal to 0 and derivative of position is velocity. So the way we would do that is we would set our velocity function equal to 0 and solve for t. And in this case, I'll get t is 3 3/8, I believe, is what this is, but your version would have been different. So that's how many seconds it takes for the thing to be at its maximum. Notice that means in 2a, when we found how high the ball was after 4 seconds, that means the ball was on its way down at that point. But so the answer here is just whatever this integral is. So instead of asking how high the ball is at 4, we're now asking how high the ball is at 3 3/8 seconds. So it's really the exact same process as above. We already have the antiderivative above, but now we're just integrating from 0 to 3 3/8, since that's where the maximum would occur. The last problem, there weren't too many people who actually remembered this exactly. It does have to do with area, but the integral doesn't just tell us the area. Let me just draw the picture. So first of all, the integral goes from -2 to 4, so it's only this part of the graph from -2 to 4 that matters. So if you shaded in more than that, then you are kind of already off base. The region below the curve, region below the x-axis and the region above the x-axis, we could shade differently. Anytime the region is below, we think of that as negative area. Anytime the region is above the x-axis, we think of that as positive area. So the integral is the green area minus the red area is going to be the integral. So in this case, they told us that was 9. So 9 units squared. So the difference, what 9 means in this context of this problem is it's how much more area there is in the green part than there is in the red part. We often say that the integral measures net area, but what we mean by net area is exactly what I just said. Net area is just treating the area above the x-axis as positive and the area below the x-axis is negative. So that's what it means. I will say something in class about how that relates to what we're doing with area between curves. That's why I wanted you to look at this here now, because it is related to what we're doing right now. And it does make sense that this is how area would be interpreted in terms of an integral. But this is what I was looking for. So if you just shaded some stuff in and said that 9 was the area shaded, then that's not really quite right. And I made a note of that, and hopefully this explanation will refresh your memory on that.